Hi. In one of my previous videos, I explained how to do simple conditional statements, so how to do simple decision making in computer programming, and I explained the if structure, the if statement, which allowed me to check for a particular condition and then make decisions whether if that condition is true or false, and it allowed me to do that by chaining, for example, a lot of if else, if else, if else statements, right? And that by far is the most popular conditional structure that I can apply, but it's not the only one. So I actually want to explain today another one, which is called the switch case statement, which is a structure that is also used for conditions, for specifying conditions, but it's more typically used when you actually have to check one condition against a lot of different options. And it's very popular because if we were to do this with a normal if statement, we would actually have to chain a lot of these if else's, if else's, if else's, which can be a little tedious to write, but it can also be a little tedious to read. But most importantly, it can be tedious for changing it, right? So what I have here is a very simple example. Let's imagine we were programming a small video game, and the small video game has a two-dimensional space where there's a character that we want to move up or down in the X and the Y directions, and we want to use the keys A, S, D, W to move the character around. This is a very common keyboard pattern, for example, for first-person shooters or for that kind of thing, right? So what we want to do is we want to have a program where every so often we check for input from the user, from the keyboard, right? And then based on whichever input we get from the user, then we decide to move the character to the left, to the right, up or down. With what we know so far, this program would look something like this. We have two variables here that represent where the character is, right? And then we have another input here called we have another variable called the char, which we're going to imagine that this is somehow what we would get from as input from the user. And by the end of this video, I will actually turn this into the user typing things in the console. But for the time being, we're just going to imagine that this variable represents what the user input, what the user is typing. And at this iteration of the console application, it just happened to be a W. So what we want to do is we want to check that variable, which is of the type character, a char, right? And we want to check that against all the four possible options, A, S, D, W. And depending on which letter it was, for example, if it was D, we want to move the character to the right, so X position Y. If it's A, position X is -1. If it's W, position Y goes up 1. But that depends on the coordinate system of the graphic environment you are. Sometimes Y, positive Y, is actually pointing down, so we need to double check that. And then S, if we press down, then we want to go position Y, we want to move down. All right. So what you can see is that I have written a conditional statement that checks for the four possible options within the letter input and then changes the variable depending on that. So actually, and by the end of the program, I print to the console what is the value of the current position in position X and position Y with this string interpolation. So if I run this code, what you can see is that current position is right now 0 and 1, so positive Y, because we moved with the W, so we moved up, right? If I were to press A, which is moving left, then what I would get is that the position of the character is -1, 0. Okay? And again, by the end of this video, I will actually do this by typing in the console. Okay? Now, this structure is okay, but it could be a little tedious to write and to maintain. So there is this other structure called the switch case structure, which allows me to write this very same logic in a somehow more elegant way and with a few other optimizations and advantages. So the way that's going to work is that I'm going to first create a switch. I'm going to write the word switch, and in parentheses, I'm going to open parentheses and I'm going to open curly brackets. At this point, you should be familiar with this way of creating structures, the word that defines the structures, some kind of condition, and then the block that is defined in the structure. And inside of the switch statement, what I want to do now is, in this case, I'm not really going to write an expression. I'm not going to write what the check is going to be. What I'm going to write is the value that I want to take a look at and that I will be using for comparisons with all the possible cases that that value can take. So for example, in this case, what I'm going to do is I'm going to pass in the variable letter input, and then inside of the switch structure, I'm going to define all the possible cases that that letter input can take. So for example, in this case, I'm going to say if I were to move to the right, letter input would have the value of D. So what I do is I write the word case followed by the value of that particular case, so one of the values that I want to write a case for, and then the colon, the colon symbol. After that, inside of this, I am going to write all the code that I want to execute if the letter input had the value of D. Okay, so in this case, that's going to be moving the position of the character 1 unit in the x direction. And after I have finished writing all that code, then what I would do is I would write the word break, the keyword break, to signify that this case, all the code that needs to run for this particular case stops here. Okay? This is very confusing because you could have said, oh, maybe we should just like wrap this code inside of curly brackets, you know, and that's how the case could be defined. It could have been, but it's actually not the case for the reasons that I will explain in a minute, right? So I'm going to get to there very soon. So keep it in mind, when you define a case, you have to write the code that you want to execute for that case, and then you have to finish that code with the word break. Because if you don't, the code will leak to the next statement, all right? To the next case statement. So now it's just as easy as writing one after the other. Okay, so now if I want to move left, then position X is going to take 1 unit less, and I'm going to stop this case. Now I'm going to type, if I want to go up, then it's going to be W, and then position Y is going to increase by 1 unit, and I'm going to break. And then if I want to move down, all right, then the position Y is going to decrease by 1 unit. And I'm going to break this as well. All right? So this structure that I have written here, this switch checking this value and then writing all the possible cases with their attached code that we should run given different values of letter input, is very, very similar to the structure that I had before here with all these nested if-else statements. Okay, so now I did A, so I'm moving to the left, and if I were to change this to, for example, W, then I would move up. Okay? All right, you may argue at this point, well, I mean, it's okay, it makes sense, this that you had before is the same as this, but honestly, I don't really see how much savings I have gotten in terms of writing code. It feels like it's almost like even more lines of code, right? And from a clarity point of view, maybe I could see, maybe this is a little easier to read, but we could also argue against that, you know? So it is true, maybe from a lean standpoint, it's not so much more optimized, but there are certain things that switch structures are also better at doing, because like in a way they allow a tiny bit more flexibility. So let me show a case. For example, let's say that the user were to input a key that we are not accounting for. Okay, so for example, let's say that the user just mistakenly pressed the letter G. In this case, the user didn't move anywhere, all right? But the user, but we may actually give the user some feedback about like, hey, I don't really know what to do with this key that you just told me, right? So so can you please press again? And if I were to do that, then I think if you were using an if structure, I would basically have to keep adding here else if, else if, else if, and account for all possible letters that are on the keyboard. And I don't want to do that, right? Similarly here, I would have to say case G and then console right line, like I don't know what to do with key letter input. All right, and break. Right? So in this case, now I'm printing, something is broken. Oh yes, I'm missing a semicolon. So in this case, now I'm printing that message to the console. I don't know what to do with letter G. So current position is 0, 0. But again, I don't want to have to copy paste this for every single key that is in my keyword. So one thing that is quite interesting is that switch statements have a very special case that is called the default case. All right? The default case is basically a catch-all. It's like the trailing, like the last else in a conditional statement. It's basically if none of the above, if you didn't find any case that matched the value of letter input, then use this one as a default. Just always use that one if you didn't find anything before. So I don't know what to do with letter G, but now also this works for letter, for example, J or K. Now this works for letter K. So now I also don't know what to do with letter K, etc. Right? So this is also a little bit more, it's giving me a little bit more flexibility. But also there is this thing, what about if the user, for some reason, didn't forgot that they had the cap locks, and instead of pressing normal lowercase letters, they were pressing uppercase letters. If that was the case, then this program would actually not work because the character lowercase a is not the same as the character uppercase a. So something that I can do also is that I can link together several cases for the same code. So what I can do here is I can say, you could think, well, then the solution for that might be just duplicating this and making a case for uppercase A, right? But this is duplicating too much the code. So actually, switch statements allow you to duplicate for a particular case to add different cases that will be using the same code. So in this case, what we have here is that if letter input is lowercase a, or if it's uppercase A, then both cases will trigger this code that we have here. It's like saying if letter input equals lowercase a and or so double pipes if letter input if letter input equals uppercase a, then execute this code here. And similarly, I can do this, and then I can add like a case for uppercasing, and then I can do uppercasing, etc. So now my code is a bit more resilient to uppercasing and lowercasing. All right, great. And I have to say though, I would argue that this structure is a little easier to read, to write, and to change based on, for example, what I can see here. For example, in this case of keyboard input. Switch statements switch structures are really popular when it comes to these kind of things. For example, detecting keyboard input, detecting mouse input, or making decisions when you have like a lot of options. Like for example, if you have to make 10 different decisions based on 10 different numbers from 0 to 9, then a switch case structure is probably like a much elegant and much more a much better structure to deal with those situations. All right. Now you may actually be wondering, okay, so how can we actually turn this into something that the user uses to keep inputting letters? So let's actually rewrite that. So what I want to do is now I want to have an interactive console application where I can keep pressing keys over and over again and start moving virtually this character and then print to the console the position of where that character is. We're not going to move that in the screen. We're just going to print the coordinates of that virtual character. So what we can do is, because what we want to do is we want to create something over and over again, what we will need to do is we will need to wrap all of this inside of a while loop, because we could use a for loop, but we don't really know how many times we want to be doing this. We probably want to be doing this until the user presses a particular key, like escape key, or the user presses a key that is wrong. And in that case, we just want to exit, right? So so let's say that I'm going to write all of this. I'm going to wrap it inside of a while statement, okay? And then I'm going to say here, I'm going to take all of this and I'm going to paste it inside of my while loop. All right. And I'm only going to paste this code. I want to leave the position X and the position Y outside of the while loop so that their value is permanent because of the rules of variable scoping, so that their value is permanent and they don't get reset every iteration of the while loop. I still haven't added any condition here. I'll get to that in a second. And then what I'm going to do, first of all, is I'm going to print to the console a message. Like, I'm going to print to the console a message. So write line, enter a key. Okay? I'm actually going to do write. Okay? And then I'm going to enter a key. And then I'm going to capture that value as a variable. So that's going to be called input. And then oh, sorry. I'm messing this up. I'm going to write that here, and then I'm going to say console read key, and I'm going to store the value of that key inside of my input. Okay. Let me take a moment here to see what's going on. All right. Yes, I forgot that before in previous examples we used read line, and which takes like a full word or like a bunch of letters one after the other, and we can store that as a string. But when it comes to read key, if we look at the signature of this function, if I hover over here, what you see is that what I get back is not a character, it's a more complex object. It's a console key info. It's an object that encapsulates more properties of that keystroke. So what I need to do, and this is a little bit more advanced, like console interaction stuff, but what I need to do is I need to change the type of the variable that I'm going to use to store that information into an object of the type of what my function is giving me, which is console key info. So I can just write here console key info, or if you want to do implicit types and you just don't want to care about typing so much, you can just do var, and then the compiler will take care of figuring out what this is and storing it in the right type here for input. It will take care of giving input the right type. Okay? I like doing things more explicit so that we know what we're working on. So I'm going to leave console key input here. And then what I want to do is I want to, for this value, to this value, I want to assign the character, the char of the letter that I just pressed. And I can do that by going to input and hitting dot, and then seeing that the IntelliSense is already suggesting that I should try to read the property key char, which is of the type character, and gives me the Unicode character that represents the letter, the keyword that was just pressed. I don't know if at this point in the video tutorials we have seen already objects with methods and properties. I hope we have. I don't know where I'm going to put this video after I record it, but if you don't, then just please go to the videos where we talk about object-oriented programming, and you will be able to understand this a little better. Okay? And then now we have the character associated to the key that the user just pressed, and then we can make decisions about how to move X, Y properties, etc., and then move the character over and over again. And then I need to put in here some condition for the code to keep executing and looping over and over again. So I'm going to write here a new variable, for example, which I'm going to call keep reading keys, and I'm going to set this to true. And I'm going to say here, while this is true, or if I want to shortcut that, I can actually just only type while keep reading key, and then it will implicitly check if this is true or not, then do this here. I'm going to run this code, and as I do, it's going to ask me for enter a key, and then I'm going to say A, and you can see that current position moves to the left. A, I'm going to keep pressing A, I'm moving to the left, and now I'm going to start pressing D. So you see that I'm moving to the right. You see how the X is moving to the right, and then I can press W to go up. So 8-1, 8-2, 8-3, or S to go down, 3-2-1, and now I can just go crazy with all these keys. And you see that if I press something that is not a key that the system knows, it doesn't do anything, and it tells me I don't know what to do with that key that you just pressed. I don't really like that the enter key is, I enter the key and then the message goes right after that. So what I'm going to do is to make this a little cleaner. I'm going to write right after here, before I print anything, I'm going to write an empty line so that I move to the next line. I'm going to say enter a key A, D, A, D, you see, D, 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 A, W, etc., etc. All right, so that's great. So this is working. However, this program is not clean yet because it's infinite. Basically, there's no way this program is going to stop ever executing, because this variable here will always be true. So I will need to force close the console just like I did right now, which is not a great it's not a great interface. So something that I can do is I can add another condition in my system to stop executing this while loop. So for example, what I can do is I can say either, for example, I can add a special case for a particular letter. So for example, let's say that I do Q for quit, right? Or that I do case, uppercase Q as well. And then here, I want to say, if user presses Q, then I'm going to exit my program. So I'm going to write a message, exiting program. And I'm going to run this code, and I'm going to say blah, 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 and I'm going to press Q, and you see exiting program, but I'm actually not exiting the program at all. Why? I'm pressing Q and it's not exiting. It's not exiting because the only thing that I'm doing when I press Q is printing to the console, but I'm actually not changing anything in my program. What I need to do is, as part of that code as well, what I need to do is to take this variable, change its value to false, so that the next iteration of the while loop, this is false, this while loop doesn't execute anymore, and then the program just exits. So what I'm going to do is I'm going to write here, keep reading key equals false. And let's see if this works now. So enter a key, A, D, W, A, blah, blah, blah. Any other letter gives me an error, etc. But if I press Q now, you see exiting program. I still print the position. And then if I press a key, boom, my program just closes. All right. So great. So you can see that we have now creating a more complex program where we can keep a global state of the value of the position of the character. We have an infinite loop that is controlled by a variable. So this variable, so long as it's true, the while loop will keep executing, and we will keep asking the user to enter a key over and over again. We will parse that key into a character, and then given different values, we will either move the position and then print to the console, or if it's a special key like Q, then we will exit the program by setting the variable that is defining the condition in the while loop to set it to false, so that the while loop stops executing, and then the program hits this last line and it exits. All right, cool. So you have this. I don't know if this is your first infinitely interactive console application, but but it's an example of that. And I hope this was interesting to learn the switch case conditional structure. Thank you very much. If you like this video, subscribe, hit the bell button, etc. And see you on the next video.